This is project 2, video number 1, the video in which I work on the pencil and paper part of the project. So you got two particles having opposite charges with opposite signs and unequal magnitudes on the x-axis, and they're in order. We're supposed to write a function that's got 5 arguments in order with, it goes charge position, angle, and the bigger charge comes first. And then we're supposed to find out how far away from the smaller charge in the particular direction specified by the angle, a point where the electric potential is 0 is. So let's draw a picture. Pick some arrangement. There are various possibilities here, but I'm going to go with we got say a positive charge here, and I'll call that Q big. So it's got the greater amount of charge, and it's at a position that I'll call X sub B. Then I'll put negatively charged particle over here at a position I'll call X sub S, so it's got the smaller amount of charge, and it's got an amount of charge Q sub S. And then I'll look at an empty point in space, call it point P, and I'll put it at say X sub P. I'll just call it XY. P at XY, where the electric potential is 0 there. It's a distance RS from the particle with a smaller amount of charge, and the direction is one of the givens. One of the arguments is the direction, the angle, theta, to it. And then at point in space is a distance RB, separation, bigger charge from the other charged particle. So the potential at that position is supposed to be 0, so I'll say the total phi is equal to phi due to the bigger charged particle plus phi due to the charged particle having the smaller amount of charge. And that would be 0 is equal to K QB over RB plus K Q sub S over R sub S. And the K's cancel. And I can write down, let's see, eventually I want to solve for R sub S, so I'm going to express R sub B. We'll use this equation to substitute into another equation. I got one equation, 2 unknowns, so I know that's not going to cut it. So I think let's back. I'll take that a little bit more slowly. I'm going to go Q sub S over R sub S is minus Q sub B over R sub B. So I just subtracted this from both sides and then switched sides. And from that I can multiply both sides by RB, and at the same time multiply both sides by RS over QS. And I've got an expression for R sub B. And the other one has to come from the arrangement here, I want another relationship. I'm going to use the geometry to get a relationship between RS and RB. This distance right here is XS minus XB. And there's a law called the law of cosines, and I'm going to use that. The law of cosines states that, let's go ahead and write it down up here. Law of cosines. Trigonometric relationship for triangles that are not right triangles. And you can pick any angle, but I'm going to pick this one because it's so closely related to theta. Alright, so this is generic stuff up here. This generic stuff is, so this is not the same theta. This is this one up here is a generic theta. You got A, B, and C, and according to the law of cosine, C squared is equal to A squared plus B squared. That's looking like Pythagorean's theorem so far, but then it goes minus 2AB cosine of theta. So in other words, you pick an angle, then the opposite squared, the side opposite that angle squared, is equal to the sum of the squares of the other two sides minus 2AB cosine of theta. So if you had picked this angle, for instance, it would be B squared would be equal to A squared plus C squared minus 2AC times the cosine of this angle. And you can see it looks like Pythagorean's theorem with a correction factor in here for the case where the angle isn't 0. Notice if theta is 90 degrees, this would be cosine of theta would be 0, and it does revert to Pythagorean's theorem. Alright, for that simple case. So I'm going to use that here, and in my case this becomes RB squared is equal to XS minus XB quantity squared plus RS squared plus minus 2XS minus XB times RS, so it's the product of these two sides, times the cosine of, I'm going to have to move over a little bit, cosine of 180 degrees minus theta. Cosine of that angle right there. Now, if you look at a graph of the cosine, this is cosine of theta versus theta, starts out up here, something like that, where this is 360 degrees, so this is 180 degrees. Now cosine of 180 degrees minus theta, you give me a theta, and it means I have to start here and then go backwards from there. So if you look at it, it looks like at 180 degrees I got minus 1, and then if theta gets to be 90 degrees, I'm 90 degrees to the left of this, which would be 0. It's working just like the cosine of theta, except for the negative of it. This is actually the negative of cosine of theta. So I'm going to go ahead and make that substitution. I get RB squared is equal to XS minus XB. Just copy it down. Oh, and you know what? I might as well make both substitutions at the same time. Let's make sure I got This is RB squared. I'll go ahead and do that substitution. I'll still be doing pure substitution, just be doing both of them at the same time. This is minus QB over QS times RS all squared. I'm going to draw a little separation line there. So I substituted RB squared with, well, for RB from this expression that I had on the left. And in fact, I think we can arrange it so you can see that too from right there. And I'm also substituting this minus cosine for the cosine there. So it's minus 2x minus xb rs times minus the cosine of theta. Alright, let's gather everything on the right, and I'll put it in the order of highest power of RS to lowest power. So I can say I got a 1 RS squared here, and over here I got QB over QS quantity squared, that many RS squared. So I'll subtract that from both sides, so I'll have a 1 on the right, 1 minus QB over QS squared. Multiply an RS squared. And then minus is a plus, so plus 2x minus xb times the cosine of theta times RS, and then plus, this is the constant piece, it's got no RS in it, so XS. That's the position of the smaller charge, minus XB, the position of the bigger charge. And that's all equal to 0. So I got a quadratic equation here where A is equal to 1 minus QB over QS. They kind of look like 9s there. Let's work on that a little bit. QB over QS squared B is equal to 2 times x minus x sub b. I think that was x sub s. Let's go up and see where they came from, because I don't believe I had a plain x in the problem. I mean, there was. That was the coordinate of point P, and it hasn't come into. I didn't use that. So XS. This came from up there, so it's just a copy error. So I had the law of cosines up there, and then when I copied it down, this XS just became an X. Alright, so that should be fixed up. Alright, XS minus XB times the cosine of theta, and C is XS minus XB quantity squared. And then the solution to that equation is that R sub S is equal to minus b plus or minus, well, the two solutions to that equation, I guess I should say, are b squared minus 4ac all over 2a. Let's see if we can see make any sense of which one I should pick there. See if there's a physics reason for picking the plus sign over the minus sign or vice versa. So this thing, QB, that's the amount, the bigger charge. One of them's negative, so that ratio is, that quotient is going to be negative, but once I square it, it's positive. So and QB is bigger than QS, so this is in magnitude greater than 1. When I square it, it's going to be bigger than 1, so this is going to be less than 0. A is less than 0. This XS minus XB, let's, I think what I'm going to do is go with the arrangement that I have. I mean, XB could conceivably be to the other side, but at least for the arrangement that I have, XS is greater than XB. In other words, the smaller charge is farther to the right. My game plan here is I'll go with the configuration that I have, go through the whole problem, and if it doesn't work, then I'll pick something else. I have an idea of what the answer should look like. Is some kind of oval around the smaller charge is going to be the locus of all points. So so with that arrangement, XS is greater than XB, and I got an angle. I've chosen a point in space such that the angle, well, the angle was given as 30. No, the angle is given by the user, but the configuration I chose has the angle being between 0 and 90 degrees, so cosine of theta will be positive, so this is greater than 0 for my configuration. So again, I get it working for this one configuration. That's not proof that it works for everything, but I'm going to try it based on this one configuration, and then we'll see how it works out and see if it gives something that looks like a reasonable answer. And then XS, we said was greater than XB, so this, well, I'm squaring something, so it's greater than 0 anyway. It's the square. Alright, so A is negative and the other two are positive. So A is negative in here. RS is a distance, so it's got to be positive for it to be a physical quantity. So this being negative means upstairs has to be negative. Let's see if both results would give us something negative. Well, with A negative and C positive, this 4AC is going to be negative, so I'll be adding something to B squared. And so I'm taking the square root of something that's bigger than B squared. That'll give me something bigger than B. So if I chose the positive, that would give me a positive result up top with a minus sign down here for the A. That would give me a negative result for RS. So I need to choose the negative sign. Then both terms upstairs are negative. The whole numerator is negative divided by the negative. A is going to give me a positive. So choose minus sign for positive R sub S. So R sub S is equal to minus B minus square root of B squared minus 4AC all over 2A. And I choose not to do the back substitution, like substitute the A in there and the B in there and the C in there. I'll calculate what A, B, and C are in the program and then plug them into here. Alright, so let's see if I think I'm ready to write the function. Alright, so given an angle, it calculates the R. I'm going to call it get R. So function I'll let the return variable be R. I was calling it R sub S, but I prefer to just call it R. And I'm going to say get R. So in other words, get that distance from the smaller charge to the point in space where the electric potential is 0. Distance measured along the line that's at the given angle. And this is going to be a function of I think it's QB XB. I'm going to check the handout to make sure I get those in the right order, because that was this one, the order is specified. XS, and then theta. And the handout, I think, was the bigger charge first. Let's make sure of that. It takes 5 arguments, namely the charge of the particle having the greater magnitude of charge, and then the x-coordinate of that, the charge of the other, the x-coordinate of that, and the angle. So yeah, I'm good. I started with the bigger one, just as I was supposed to. Alright, and then, so this is my outline. First function. And so I get all these as arguments. And notice I don't even need the k. The k was in the problem but never used it. So k didn't matter. I think I just have to, maybe I'll leave a little space in case I think it's something else. But I think I just have to calculate a, b, and c. Use yeah, I think I'll go ahead and copy them down here. So A equals, what is it, 1 minus QB over QS, quantity squared. B equals, seems like there was a 2 in that. I gotta look, see if I got A right anyway. Yeah, that looks good. And then 2xs minus xb times the cosine of theta. xs minus xb all times the cosine of theta, and c is equal to xs minus xb quantity squared. xs minus xb quantity squared. And then r, there's the return variable, so I'm assigning a value to the return variable, is minus b minus, so to take the negative one, b squared minus 4ac all over 2a. And I think that's it. So I didn't leave much space in there. If I do have to pop something in there, but I think that's it. Let's try the other one. So the other one, it's a function outline of the second function mentioned in the handout. Function. This one draws a graph, so it doesn't return anything. So I'll use something that says I'm not really using this, and I need a name of it. So it's making a graph of the points at which phi is 0. I think I'll call it the electric potential is 0. I'll call it plot phi 0. This one's only got 4 arguments, and the thing was you didn't know what the order was, so I think I'll call them Q1, X1, Q2, X2. I mean, it had to go charge and then the position of that charge and then another charge and the position of that charge. But of the 2 charges, they have to be of opposite sign, but we don't know which one has the greater magnitude. So actually the first thing we have to do is set Q1 equal to, no, I'll call it QB is equal to bigger of Q1 and Q2, and XB is equal to the position of the bigger. And maybe let's say it's whichever one has a greater absolute value, so we're not worried about to the right on the number scale. That's what I mean. And then QS equals the other charge, so smaller of it's really not quite that. Q1 and Q2. So I should maybe say it's a charge of particle having a bigger absolute value. The way I had it before, somebody reading it might think that QB was an absolute value. It's not. It's the actual charge of the particle that has the bigger absolute value. So position of bigger charge mag. And then I think that's close enough, not grammatically very good, but conveys the idea. So what do I need? This, I think. So charge of particle having smaller absolute value of charge. Alright, charge particle having smaller absolute value of charge. And then this is position of the particle having smaller absolute value of charge. Alright, so in other words, I got to get them sorted out, get them in order, because the other function needs them in order, assumes for them to be in order. And then let's create an array of angles. Theta, I'm going to go 0 to 360, and I use 361 steps. So 1 to 360 would be 360 steps, and 360 values, and then I'll also have one that's 0. Alright, that's the lens space. So let's go ahead and squeeze a lens space in there. Equals linear spaced array of values that go from 0 to 360 in 361, well, with a total of 361 values. Alright, then I think I am ready to call R equals get R of QB, XB, QS, XS. Alright, then once I got that, I have to to do a little bit more work. If I know what R is, then I got to get the coordinates X and Y. So I'll say, I think I haven't used these yet, so I think I will call it, yeah, just X and Y. So X is going to be equal to all the way over to this negatively charged particle, which is X sub S, plus RS plus this distance right here, which will be RS cosine of theta. And then how high up I am is just going to be RS sine theta. So this will be Y RS sine of theta. It looks like I got a little dot there that isn't needed. So Y equals RS sine theta. So XS plus RS cosine theta so X equals XS plus R cosine theta. So I've been calling R sub S just R. And I think that's what I called it in here. And Y is equal to just R times the sine of theta. And then we have to plot, presumably here, theta is an array of 361 values, and then when I go to get R, I'm going to get R for each of those 361 values, and now I've got the coordinates of all those points, and I want to make a graph of Y versus X. So plot X comma Y. Oh, and I have to plot on the same thing. Plot just the position of the two charged particles. So it's XB comma 0. The two particles are all on the y-axis, and plot XS comma 0. So this just puts one point on the graph. I think I'm going to need a symbol for it. I think I'll choose an X so you can see it. But I think that actually does it. So that would be the end of this function. And I don't know if I wrote end on the other one. Don't really have to for an outline, but looks like I did. So here's the outline of the second function starting right there. So I'm going to call that a wrap for video number 1 for this project, but keep in mind sometimes when I'm doing the programming I find that some mistake in this part of it. They kind of go hand in hand, so it's better to do the programming before you turn in the pencil and paper part. But you guys want to make sure you look at the other videos to see if I came back and changed something in this pencil and paper part besides just doing things like erasing things that I had crossed out. And I think I'll fix that. That was little bit of overkill there. So messed that up a little bit. And then with a small eraser. Charge a particle having a bigger absolute value of charge. Charge a particle having, direct somebody's attention, bigger absolute value of charge. Okay, let's call it a wrap for project 2, video number 1.